Managing Databases Part 1 of 3. In this nugget, we initiate a 3-part mini-series on the creation and management, otherwise known as the care and feeding, of databases in MySQL 5. We'll begin with an architectural and theoretical overview of good database design. What factors go into designing and developing a database before we log into MySQL and use those DDL statements to actually build your data files? Second half of this particular nugget deals with creating databases. We'll not just be dealing with the SQL here, we'll also look at data file location, changing data file location, and other various and sundry topics that are related to this. Let's get to work. Relational database theory. As I mentioned to you in the opening nugget of this series, the MySQL Associate or CMA exam isn't going to test you on stuff like whether you know that Edgar F. Codd is considered the father of relational databases. This is stuff that, while you're not going to be asked for it on your CMA exam, or even, quite frankly, specifically on your DBA exams, I think, as your instructor, I would be remiss if I didn't at least hand over these two founding fathers of relational database theory's names to you and give you the names of their landmark texts. First, we have Edgar F. E.F. Codd, born 1923, unfortunately deceased as of 2003, and as I mentioned, this guy is considered the father of relational databases. His chief text, and really it's the text upon which most other hardcore foundational books on relational database theory are derived, is called The Relational Model for Database Management. I'd encourage you to look it up on Amazon and purchase it. The second name I'd like to give you is C.J. or Christopher J. Date, 1941, and he's still alive. Chris Date is a colleague, or was a colleague, of E.F. Codd's and believes in the same relational database model that was originally pioneered by E.F. Codd. Date's landmark text, he has several, but the one that I recommend you read if you're interested in getting into the theory is called An Introduction to Database Systems. And like I said, you can find more current contemporary books on database theory, but I would bet you $20 to a stale jelly donut. Almost all of those books are going to owe a huge allegiance to one or both of these two men. Look them up on Wikipedia, read their books, and then we'll go on from there. Database design steps. Before we get into the nuts and bolts of MySQL implementation of creating databases, I wanted to just show you the 4 basic steps. These are commonly held principles in the industry for designing a database. The general principles. And really, you'll find this tested in industry, that any database developer worth his or her salt is going to follow some combination of these 4 points. The first one, some might say this is the most important step. Think of any project you've developed, whether it's something at home, a home improvement project, or at work if it was a software design project, or a purchasing project, or a server upgrade project, or whatever it is. Unless you do a thorough needs analysis and try to get things right on the front end, you may wind up hurting pretty badly once the project is underway and the project builds to the point where making fundamental changes is either impossible or next to impossible, right? So the requirements analysis deals with stuff like you performing industry analysis to figure out what kind of data do we want to track for this particular database, and how are others in this space tracking this? You'd be working with a client, or maybe you're doing a database design for your boss. You'd be doing interviews, site visits. You'd observe the workflow going on in that company. You might distribute questionnaires to gather data. All of these kind of things to get a feel for the workflow that's surrounding the database you're building and figure out exactly what needs this database will meet. So again, this is a crucial step. You need to invest a lot of effort in your requirements analysis. Once you have all that quote-unquote soft data, you then move on to what's called the Entity Relationship Diagram, or ERD. Now, some database designers will conflate my steps 2 and 3. I have them broken out into ERD and what's called a relational model. You'll see what I'm talking about as we go along here. But in a nutshell, an ERD is simply a user-friendly way of graphically mapping your requirements analysis. So you might be thinking to yourself, all right, let's say you're developing a financial application database, and you're thinking, okay, we've got customers, we've got products, we've got vendors. You're thinking of all of the entities that you'll be needing to track, and just in general, the relationships that link these entities. Not only are you looking at the relationships, but you're also thinking of the attributes of each entity that you might want to track. For instance, with customer, what kind of data would you want to keep on your customer? First name, last name, address is a no-brainer. But how about some other stuff, you see? So your requirements analysis, the output for that, serves as the input for your ERD diagram. Whereas traditionally, the ERD is not dealing with technical terms like primary keys, foreign keys, and all of that stuff. Like I said, some database developers cut to the chase and they create what's called an enhanced entity relationship diagram, or EER, and build what's called a relational model. This is going to be a graphical representation of the database that shows, again, all of your entities, but this time your entities broken down into a proposed table structure where you're literally taking those attributes that you're tracking for each of the entities and mapping them to columns and data types. We're not just going into MySQL and using the create database statement willy-nilly. We're using the create table statement willy-nilly. We're going to map all this stuff out in great detail in advance to make sure that we've planned it correctly. The MySQL Workbench tool is a free open source project available at mysql.com that can make short work out of creating really beautiful EER diagrams. I'll show you this in the demo actually. We'll spend just a moment on it. And then finally we have the issue of what's called normalization. Now, what does normalization mean? It gets a lot of press among college students who are studying programming or database theory, and initial newcomers or newbies to DBA work are afraid of it because they feel it's overly or needlessly complicated. But let me break it down for you. Normalization is simply a process of reducing or eliminating data redundancy in your database tables. So it's whittling down or paring down your ERD, your EER diagrams into a finer, more granular format. So whereas you might have an initial entity diagram that has 10 tables, by the time you're satisfied that you've normalized your database to the preferred third normal form, you might have twice that number of tables. Now somebody, a newbie, might say, well, isn't that bad? Shouldn't a relational database have a small number of tables? No, not really. Really, there's no bad or good here. The point is, you want to reduce redundancy. You don't want to have the same data being tracked in two tables. You can see instantly, I hope, why this is verboten. If you've got the same data being tracked in two different tables, then we've got the possibility of user error producing out of sync data, incorrect data. The list goes on and on. You see what I'm saying? The 3 degrees, and there's actually more than 3 degrees of normal form, I would suggest you hit up Wikipedia, go to bing.com or Google and do some searching if you want more theory on this. This is just all background info so that you can be a really well-rounded MySQL administrator. Your first pass to put your database in first normal form means that your tables exist with no duplicate columns, just as simple as that. The table is atomic. That should be pretty easy to do. Second normal form means that you've met first normal form, and then you go about identifying and separating subsets of data that can be reused. What that means in layman's terms is that you might have, let's say, a products table that stores product name, product category, and so on, and then for some reason you might have columns dealing with quantity ordered, sum total. You might have columns that really shouldn't be tracked in the same table as the rest of those columns. So what you're doing in second normal form is looking for groups of columns that can be broken off into their own separate tables. You want to look for as granular a database design as possible. Remember, an old mentor of mine said to me once, Tim, the best number of columns that any database table should have is 2. You should have an ID column and some unique attribute that you're tracking. Obviously, that's theoretical more than practical, but that's what we're getting at here in second normal form. Finally, when we get to third normal form, all of our tables have satisfied the constraints of first normal form and second normal form, and here the deal is you're removing all data that's not directly related to the primary key. In other words, you want to make sure that every column in that database table depends upon the primary key for its uniqueness. This speaks to what we've talked about earlier about the importance of the primary key to uniquely identify every row in a table. All right, that's enough theoretical stuff. Let's turn our attention to MySQL 5 in particular and some topics that you're likely to see direct coverage on your CMA exam. Creating a new database. Here we turn our attention to MySQL in particular, and we see the Create Database DDL statement. Now I've thrown in some extra parameters here just to show you how they work. Create database, and then the name of the database. You don't want to use spaces, of course. We'll talk in just a moment about case sensitivity. This is a sensitive, pun intended, issue with MySQL. As best practice, you can throw in this if not exists clause whenever you create a database or really any object in MySQL. The if not exists identifier is useful as a safeguard because what it will do is instruct the MySQL parser to check if the object exists in the current database before you actually create it. So in this case, we'll be telling or instructing MySQL to create a database called testDB, and if there happens to be a database by this exact name on the current MySQL server, then you'll simply get a response back, query OK, 0 rows affected, and nothing will happen. And this is nice because we certainly don't want to unintentionally blow away an object like a database or a table. So if not exists is cool. Other things you can throw in are specifying a character set and a collation for that database at creation. Of course, you can also alter a database after a database has been created if you need to make additions or subtractions to these parameters or others. Now then, more about identifiers and case. We've talked about this before, and we'll probably talk about it again. I draw your attention to the page in the MySQL reference manual, Identifier Case Sensitivity. That's going to be your Bible, so to speak, your go-to page for this. In MySQL, the object naming convention is database.table.column, and depending upon how you're connecting and what you're connecting, you may want to specify more than just one piece of this puzzle. Database.table or just table. It depends on whether you've attached to a particular database or not. But notice that you can even go within a table schema and reference a column in your SQL by using table.column syntax. So this brings up the point of case and case sensitivity. Really, the best advice I can give you is just to work with your team on adopting a standard and sticking to that standard as closely as possible. Really, with MySQL, you can't go wrong if you just leave everything in lowercase, quite frankly. Remember that MySQL runs on a variety of different operating system platforms. We have Windows, which historically is a case-insensitive operating system and runs on NTFS file system, which again is case-insensitive. On the other hand, the NIX variants in Mac OS X, which uses the FreeBSD, again, Unix kernel, we're dealing with just the opposite, complete case sensitivity and file systems that support complete case sensitivity. So in general, MySQL respects the host operating system with regard to case sensitivity. Columns are never case sensitive. You notice in past demos and current and future demos, I write my SQL code typically in lowercase, so it doesn't matter if a column has been defined in uppercase or mixed case. Columns are never honored with respect to case, fortunately, in MySQL. However, you can get into some trouble when you define your databases and tables if you're using a non-standard case. Again, lowercase may be the best way to go. Finally, to help us with this very confusing issue of object and identifier case sensitivity, we have a system variable called lowercase table names. And depending upon how this parameter is set in your MySQL option file, if you set this value to 1, then table names are stored in lowercase on disk, and table name comparisons are not case sensitive. If you set this particular parameter to 2, then table names are stored as given, but compared by MSQL in lowercase. This option also applies to database names and table aliases. We haven't talked about aliases yet. More on aliases as we go along. MySQL data files. Now, where are the databases actually created when you use the create database statement in MySQL? Does it depend, for instance, on whether you're using Windows, Mac OS X, or NIX? No, actually it depends upon the path in the datadir value of your option file. I hope you see by now the vital importance of mastering that dadgum my.ini for Win or my.cnf for NIX operating systems. The datadir allows us to put in a path, and I'll show you this in the demo, that will be the default storage location for any databases that you create in MySQL. It's as simple as that. And as far as the actual file extensions and file formats, this is really going to largely be dependent upon the storage engine that was used for creating the database, and then as you build your tables, the storage engine that's being used for those tables. Now remember that MySQL 5 uses the MyISAM storage engine by default. So what you're seeing over here to the left of my blue split line are the file extensions used for MyISAM databases. We have separate files, .myd files for the raw data file that stores the bulk of your rows. Each table, the schema, the table definition, columns, data types, parameters, etc., all of the schemata there is stored in a .frm file, and you'll have one data file per database in MyISAM and one FRM table file for each table. So therefore, if we have a MyISAM database called test with 100 tables, we'll have 100 FRM files. As we index those tables, we'll be instantiating additional files in our datadir. These have the extension MYI. If we decide to introduce automation into our database, trigger files pick up the extensions TRG, TRN. In the root of our datadir, you have server-wide log and status files. You'll see .log files, .pid files, and .err files. Now, the InnoDB storage engine, which a lot of DBAs prefer over MyISAM, chiefly because of InnoDB's support for transactions, tends to put all of the data into a single file called IBdata. You'll still have your form files for your table schema, but everything else, data and indexes, all gets slammed into one or more IBdata files. What about the MySQL sample databases? We've referred to this before. I'll mention it again in passing. You certainly, at the start of your learning curve anyway, want to get MySQL Community Server installed on one of your own personal machines. You don't want to be learning MySQL by horsing around on your company's production instance. And you'll want to hit up the documentation site at mysql.com and download one or more of these sample databases, or as the MySQL team calls them, example databases. Now, one of them comes with MySQL Community Server. You'll find the test database comes in when you do a standard vanilla install. Now, on production systems, you'll want to drop this database straight away in the name of reducing the surface area or attack surface of your MySQL server. Now, what is an attack surface? An attack surface represents all the possible points of entry that an illicit or unwanted user can attack or at least hit, connect to your server. So if you have a database in there that's just sitting there, especially something like test that's given to you by the MySQL team just for testing purposes, If you're not going to use it, dump it. Use the drop database command and get rid of it. Now, as far as example databases that you can download from the site, we've been dealing with the World Example Database. This is a good database, number one, because it's well documented, not just at mysql.com, but if you purchase any of the MySQL Press books, in particular their certification study guides, all of their sample code is going to be using the World Database. So if you have a copy of this running on your test server, you can follow along with those examples. Therefore, the MySQL Certification and Training Group is standardized upon the World Example Database. MySQL 5 really was quite an improvement from MySQL 4. Accordingly, the MySQL team developed the Sequila sample database, which runs only on MySQL 5 or later. Sequila, just by point of trivia, is the name that the MySQL team gives to the dolphin logo that you see with the MySQL logo. So you've got Sequila the dolphin, just like you've got Tux the penguin for Linux, right? Now, some sample databases I haven't listed here. There's a really big one that you can download called Employee. This is a very large data set. And then there's another one called Menagerie. Whether you need them all or not is completely up to you. Typically, these come down as fully documented .SQL scripts, and as you saw from watching earlier nuggets, we can log into our MySQL server and use the source command to process those SQL files and bring those sample databases to life. Getting to know a database. Once we've used the create database statement to build a brand new database, or if we've decided to download and install one of the example databases, or if you're in the field as a MySQL consultant and you want to initially gain some insight into your customer's database, what are some commands you can use? Well, some of these we've seen thus far, and believe me, we'll continue to see them as we go along. We've got the use command, which is crucial for us when we log into MySQL to attach to a specific database. This makes running query operations on a database so much easier because we don't have to specify the fully qualified name database.table. We can just specify table because we're already operating in the context of that database. Another set of commands that's important are the show commands. Now, show is not an ANSI ISO SQL statement. It's a MySQL extension to the language. However, I happen to be a great fan of it, and I hope you will too. Show databases is going to return all of the databases on the current server. Once you've used a database, you can show the tables that are contained within that current database. Once there, you can use show columns to retrieve columns from a particular table. You can show keys from all of your tables, etc. Finally, we've got this really handy describe command, which shows us when we use describe table name, the full schema of that table. Columns, data types, constraints, and so on. In our demo, we're going to start by installing the Sequila sample database. Then we're going to create a new database from scratch. Once we've accomplished those tasks, we'll use some of our other MySQL, or should I just say SQL commands, to play with those databases and learn more about them. Alrighty then, let's work with creating databases in MySQL. To begin, I'm going to show you that datadir parameter in the MySQL option file. We referred to this in the whiteboard portion of this nugget. You'll recall that my.ini is the name of the MySQL option file in Windows. My.cnf is the name of the same file on Macs and Unix and Linux. Regardless of your operating system platform, the parameter that we're talking about, datadir, is the same for all of your operating systems. So about 1/3 of the way down the file in the MySQLD section, you see we have a commented line that says path to the database root, datadir equals, and then in double quotes you have on a Windows machine C:, blah, blah, blah. This is either going to be a local path or a universal naming convention UNC path that MySQL Server will use for a default storage location for your databases. Now note also, I've referred to this before, it's a little bit uncommon. On Windows systems we use the / character. On Linux we use the /. So even though we're using Windows directory paths, we're using the / delimiters in those paths. So definitely keep that in mind with MySQL. And you'll notice that with MySQL 5.1, when you do a vanilla installation on Windows, the data dir defaults to C program data MySQL Server 5.1 data. Now I can change that if I want to, but I'm not actually going to do that. Remember also that by default on a Windows machine, your my.ini file, your option file, gets stored wherever you install MySQL Server, which, if you just do a vanilla installation, is going to be C program files MySQL Server 5.1. The next thing I wanted to show you was the data directory itself. I have a shortcut here on my desktop for easy location, and this is bringing us, sure enough, to program data MySQL Server 5.1 data. Find here are your server-specific files that I told you about. There's a .air file that picks up the name of the server. This server is, of course, called MySQL Nugget, and a PID file, mysqlnugget.pid. These PID or PID files are process ID files, otherwise known as status files. Besides the log files and the status files that map to the server level, I also mentioned that by default for every database you create on the server, you'll wind up with a separate directory created for that database. In this case, we have the MySQL directory that stores all of the server-specific metadata. This is a crucial database that you must not delete. There's the test built-in test database that's given upon MySQL installation. And as we've been working with thus far in this nugget, here's the world database. Now if we go into world, we can see a typical MyISAM storage engine based database. I'm going to do, actually these files were already sorted by size descending to put the data file up on the top. You'll notice that MySQL created a data file for each table. In other words, we have city.myd and country.myd. Remember that MYD and MyISAM are the MyISAM data files, hence MYD. City must have an index on it because MyISAM index MYI. The extensions here are pretty reasonable, aren't they? And then as I told you before, the tables are also described, their schema are described in these FRM files. Remember that when we create a database, you can specify optional parameters like collation and character set. Those optional parameters are stored in a separate file here called db.opt. Alrighty, so let's back out of world, and that's really it. Now we're going to spend a moment here by bringing in the Sequila sample database. This guy works a little bit different. It uses the InnoDB engine, so we're going to see some different files get laid down in our data directory. I also want you to see that when you download the Sequila package from mysql.com, besides, let me do a sort by type here in Windows Explorer, besides the SQL script files that actually give you the schema or structure of the database, and the data file, which gives you the actual row populations, you can see the difference in size here. The schema file is 23 kilobytes, the data row file is 3.1 megs. Besides giving you these, the MySQL team gives you this really nice PDF file that gives you a full description of the Sequila database, its introduction, its history, installation instructions, and you'll also see, sure enough, an entity relationship diagram, a pretty detailed one. And you might look at this and think to yourself, wow, how can I create something like this for my own work as a MySQL developer? The answer to that, friends, is by downloading and installing the MySQL Workbench. You'll remember in an earlier nugget when I showed you where to go to download the MySQL binaries, you can download additional programs. Well, MySQL Workbench is one of those programs. This is a free database modeling tool that's especially helpful for this kind of stuff. There's lots of other tools out there that you can use to create these entity relationship diagrams, but I think you'll like this one in particular because A, it's built by the MySQL team, and B, it plugs in seamlessly with the MySQL infrastructure. Matter of fact, you'll notice that Sequila, the download package, comes with a .mwb workbench file that you can double-click and open in the Workbench application and get right to work at understanding a little bit of how to use Workbench and certainly more about how the Sequila database works from a schema point of view. While you should be aware of the existence of MySQL Workbench for your certification exams, you won't be tested on its use specifically, so we're not going to spend any time in detail on this tool. I would advise you to download it and learn how to use it though. It's really cool. You notice that the two main tabs on the interface, the Model tab, which enables us to see the schemata of the currently loaded database. You can look at tables, views, routines, and so on. And then the actual diagram that you build. You can build out your tables, your entity attributes, in other words, your columns, your data types, your relationships. Really, really cool. This is a detailed, enhanced entity relationship diagram. All right, enough of that. Let's fire up the MySQL client application. You see I'm already logged in, and I'm going to use the source command to load up the Sequila database. Now in this case, remember that the schema and the rows are in separate files. So hopefully it makes sense to you that we're going to need to load the schema and lay those objects down before we can bring the rows in. All right, use the up arrow to bring back my source command, save myself some typing. The second file was called Sequila data, and we're good. Let's do a show databases. And now I have my information schema, MySQL, test and world, and sure enough, there's Sequila. Now, as far as creating new databases, we can say create database, db1. Whoops, I hit enter and you notice what happened. We received a new line character. Couple things we could do here. We could add more text if there were more parameters to add. Note that if I'm hitting backspace, which I am now, MySQL is not allowing me to come back to the previous line. Therefore, I can either hit semicolon and enter to submit what I've typed thus far, or do you remember what to do to back out? The escape character \C. I'm going to up arrow a couple times, create database db1 semicolon, and there we go. Create database if not exists db1. You notice that nothing happened. Okay. I tried to create a database with the same name as one that already exists. Sure enough, if I do a show databases, I can see that db1 does show up in the list. Therefore, I can drop database db1. Now you notice that we're not given confirmation. Those of you who are used to working in more hand-holding operating system environments like Mac OS X or Windows are used to a command as significant as drop database giving you a confirmation saying, are you sure you want to do this? Note that as soon as you hit enter in this case, that database is gone. So please remember that MySQL, at least from the command line, is akin to, well, in some senses, it's more volatile than editing the Windows registry. It's less forgiving. Therefore, we now can do our create database if not exists with no problems. Now let's use the use statement. We'll say use Sequila, and we'll say show tables. You see that the Sequila database has quite a few tables. Sequila looks like, if you look at it, store, staff, staff list, films, customers, city. It looks like, and you would be right if you guessed, a database that tracks a video rental store operation. Yes, and that's true. So you might ask yourself, well, cool, well, let's take a look at some of these. Which of these tables do you think would be most interesting? Well, if you're a movie buff like me, you're probably interested in looking at the film table, aren't you? Well, we can use the describe statement, first of all, pass in the name of the table, and let's see what it gives us. Now you notice the command window here is pretty cumbersome. And here's a tip, by the way. At least in Windows, the default size of your command window, or in Linux, Mac OS X, your terminal window, may not give you as pretty of a picture as you're seeing now. Believe me, this is pretty ugly in my opinion, but if I didn't change my screen size in the properties, it would look a lot worse. In fact, you wouldn't even be able to see the null, key, and default columns. They would all be smushed together. What you can do in Windows is use the command box here, come down to Properties, and I would definitely recommend you mosey on over to Layout and modify the screen buffer size. Change the width up. I've made it 120 characters, height of 300, and so on. That way it'll show a little bit more on, actually a lot more, horizontally. You may recall, friends, an escape character, \G, that enable us to display our results vertically. This avoids some of the problems with this horizontal display. So therefore, let's use the command describe film \G and see if that makes things a little bit better. I think it does. This shows us the rows in the table. Remember, describe says, don't show me the rows in the table. Give me the columns, or fields as they're formally called, their data types, their nullability, whether there's a key constraint attached, whether there's a default constraint attached, whether you have any extra parameters, you see? I've just relogged into my SQL, and I'll run a show databases. And I showed you the use command where you can establish a persistent session with a certain database. But what if you had a client, or your own company for that matter, where you needed to scan the table listing of a number of databases very quickly? You certainly don't want to use the use statement and then do a show tables over and over and over again. This is a little faster. Without the benefit of the use statement, you can say, for instance, show tables from Sequila. You see what I mean? Show tables from world. Kind of nice. Finally, you'll remember the syntax we discussed earlier in this nugget, such that in MySQL we go database.table.column. Therefore, if I wanted to do a describe of the film table from Sequila, I could say, even though I'm not currently using Sequila, describe, and then check this out, Sequila.film. You see how that works? So you're just qualifying. And I can prove again that works. I'll use the world database, and if I just say describe film, obviously that's not going to work. You see, table world.film doesn't exist. It's the same thing here. The MySQL server needs to be able to resolve these object names to an entity on the file system. Therefore, the state of whether you're using a database or not is going to guide your decision whether or not you need to qualify the table name to an associated database, or even specifically a table name to a column name. Managing Databases Part 1 of 3 Review. In this nugget, I introduced you to some of the fundamental principles of planning databases. I hope you feel more well-rounded in your understanding of A, some of the major players in the relational database world, namely EFCOD and CFDate, B, the 4 basic steps of planning a good database, and C, how to actually create databases using MySQL 5, and once you've built those databases, which SQL and MySQL specific commands are most appropriate to gather metadata about those newly created objects. I hope that this has been informative for you, and I'd like to thank you for viewing.